today's episode,
and eventually nobody touched it.
ancient technology,
This is so fancy, yeah.
or
And the sun was creating this clearing on those antennas.
arcane wizardry.
Unfortunately, this POS didn't do that.
There must be a time where people stop using those protocols. I don't know. Like the last people who heard about those protocols will die, and then what happens?
Welcome to Cisco Tech Stories. A podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan.
Hello, and welcome to another episode of the Cisco Tech Stories podcast, a podcast where we listen to outstanding stories from our guests all around the world. We're your hosts, Nico and Tristan, technical leaders in Cisco EMEA.
Hello, Nico. How are you?
Good, thank you.
Cool, man. Today I'm very excited because we have one other very interesting episode, and this is coming from one of my direct colleagues, Alain. He is actually the one who interviewed me when I joined Cisco 15 years ago. And one thing that struck me from the get-go, from the beginning, is that he amazed me with his knowledge of many protocols, and especially old protocols. Alain has a lot of experience from before the internet existed, right? So back in the days of serial analog modems, and even before that. So Alain is super experienced and always struck me with his knowledge. When he interviewed me, I was so nervous. I knew him because he has kind of a reputation of knowing a lot of things and a lot of old things, and I was so nervous for this interview. I felt not prepared. I was like a grad out of school almost. And I was thinking, like, he knows the protocols in and out, like the bits, the bytes, the sequence, the whole Aussie stack in all direction, and it's crazy. And I'm like, okay, what question is he going to ask me? If he asks me a question on those old protocols, I will never have an idea on what the protocol is, and it will destroy me from the get-go. But at the end, I made a lot of mistakes in my interview on the question that he asked me, but he was very helpful in the sense that, okay, not everybody knows everything, and just try to think if whatever you are telling me is making sense. And I was like, I know you're right. It doesn't really quite add up. And then it was like, yeah, I see that. I see that you understand it. So okay, that's fine. So it was actually very nice during the interview. So I was quite a relief after that. At the end, it turns out well because I'm still here. So
Yeah, all these buzzwords that we keep hearing all the time, I think that's just to push new technologies. It's not because you hear those buzzwords that this is what everyone adopted. And same thing for automation, etc. So we keep talking about a lot of things, but there's a lot of companies, networks that still rely, on old processes, old protocols, etc. And what's funny to me is that even, every device goes end of support after some years. There's an announcement for each of them. Sometimes some protocols or some ways of doing things keep, lasting forever. And we keep getting tech cases about, okay, new devices, but they have to somehow tolerate the presence of another old device or an old protocol that keeps need to be forwarded. So especially thinking about the industrial environment, where sometimes replacing specific devices is too costly, or even sometimes just impossible because they're not manufactured anymore. You have a factory running using specific devices, and yes, they don't support any of the new protocols, but like it's the way it is, and the factory needs to keep running. So sometimes you have to change the whole infrastructure and change a lot of other stuff just to keep supporting that specific device that does not behave the way you would like to behave. Another usual suspect is the banking environment, where things move very, very slowly. Well, I guess it moves very fast in some part of the banking environment, but very slowly in other parts of the banking environment. So that's really typical challenging domain. So that's interesting.
And I'm sure that the episode that we'll have today will be super interesting to you, and you will see that something very funny. Today we are in this world of cloud native architecture, AI, and all those buzzwords. But a lot of the daily tech that we need rely on very old-fashioned protocols. You will see that today if you didn't know already. So this is kind of the conundrum that we are in, right? These new protocols on one side, but also very old protocol on the other side.
Good for you.
Yeah, indeed. So let's welcome Alain Lanssiers, technical leader in Service Provider Tech in EMEA. Hello, Alain.
Hello, Alain.
Hi, everybody. Tristan and Nicolas.
Yeah.
So can you tell us who you are in a few words?
I'm at Yale. I started at Cisco 20 years ago. Before that, I was working for other companies. And actually, I joined Cisco because of the wide area network I knew at that time from the previous company. And a bit of routing at the time. It was not that much. Was OSPF was the biggest one. I think SIS was not even there yet. So yeah, that's when I joined.
So you had experience with the early routing and service provider directly.
Yeah. Okay. Yeah. Originally, when I joined, there was not that much of the internet. Actually, it was starting because Cisco was starting it, and at the customer, we didn't have much internet. It was a lot of stuff of wide area and serial stuff like BSC still at that time from IBM and stuff like this. And this X.25 protocol that was used a lot by customers.
So now you're in the cable team, right? And access team. It's
cable, broadband, a bit of mobile wireless with another team. So
a lot of things service provider related. Okay.
Yeah, and actually, this X.25 is still around. Last year, I had some case to solve with some customers. So it's crazy after so many years. I think it must be only 10 years younger than me, this protocol.
So you have a story about X.25. I already don't know too much what X.25 is, but can you like start from scratch and say, okay, it came as a tech case, right? A tech case you got involved in.
Actually, it was a tech case from an engineer that I was just monitoring at the time because of X.25. I was one of those that knew this protocol and at Cisco. But the X.25 was, at that time, used in a lot of places. Not only for transaction between bank office, but also you had topologies with asynchronous device that were this point of sale. The one in the shop where you slip the card through. And those were async, and they were eventually transporting the data, the bytes, through X.25 to a server. And there was a lot of topology. I mean, I'm still talking about 10 years ago, it was still around these topologies because these X.25 server were difficult to replace. They had to go through something completely else. And that was actually the case. The customer had those topology was in Greece with point of sales. And eventually there were a lot of rules. And even on the async side, there were rules that were X.28. And some of the rules in that X.28, I don't know who invented it, was that if the POS was connecting at a very small speed, low speed, and I'm talking 1,200 boats.
Wow, 1,200 boats. Okay.
Yeah, I mean, the beginning of communication, 1,200 boats was fine. You at least had some. So 1,200 boats was actually not that important for those devices because they are like maybe 128 bytes transfer for a transaction that you were doing in the shop. And,
so it's not even 1 kilobit per second, right? At that rate.
No. But I mean, I don't know if you remember 10 or 15 years ago when you were going to the shop and eventually doing a transaction, it could take 1 second. So nobody was really, it was not that important.
1 second, you're nice. I think even 5 to 10 seconds was also okay.
Could be. So anyway, that was when in the modem side, they were doing retransmission also if the packet didn't arrive correctly. Because they were, within the asynchronous modem, you could do correction. And that was also one of the advantages that if your transaction was not complete, you didn't have to transfer it to the server because you didn't receive it. The modem was correcting. And eventually, if the transaction came, then the router was starting to read the bytes. And eventually, like I said, this rule of X.28 at low speed was that you had to add 2 padding bytes. So not really data, but the rule was that you had to do 2 padding. If you were going to 9,600 baud, the padding weren't needed. But so that POS needed to have some intelligence that when you detect that the speed was 1,200 baud, to add the padding and eventually remove them if the speed was higher. Because if the line was better, the speed was higher. That's something that you could not really control, I guess, as a provider like a bank doing this POS. It was depending on the telco.
So the problem was not so much because the speed was slow, it's because typically the speed is slow because the line is bad. So this was required because line was bad, right?
So, and unfortunately, this POS didn't do that in Greece. And eventually they were looking for a vendor that could help them. So they went around, I guess, through different vendors, eventually Cisco. And then the SE, system engineer, provided the devices and everything to test, assuming that we could do it. We did. I mean, because they had trouble, they didn't know what the trouble was. And so they opened the case with Cisco later on because it was also not working. And I was looking at the case and I thought it must be this padding. So I didn't have the confirmation because you cannot really sniff on the async and sniff. I mean, you can sniff on the async, but the customer never had anything, to really sniff. It was too expensive.
Are we talking about a PCAP at that stage, or you can even print it on the screen, right? At that speed, you can read it live. Or...
yeah, you could. There are some tool like monitor, but not in that device. At some point, you had some monitor lines. But previous to Cisco, I was often doing asynchronous. I think we still have one hanging around in the office. This HP could actually do it. So eventually, I was assuming it was that, but the customer couldn't confirm. And so I asked the BU to, I mean, we knew that when he was connecting 9,600 bots, he didn't have trouble, but lower he had. So there was a pretty much confirmation that this was the trouble. So I asked the business unit if they could provide a feature, but they were busy with some other stuff. Also, iOS XE was coming in, and they eventually had to force him to implement X.25 in iOS XE because some customers were still in need of those. So no, from that side. So what I did, I could still have access to build image and so on at that time. I actually code the feature myself on a Friday evening. I remember my wife was looking at some reality show, and the laptop was on the side of the sofa, and I was coding the feature. And eventually, then I had to retest because I thought if I changed something in that code, it could affect other people.
So you don't want to break. You don't want to break everything just for one feature.
Because this padding and this rule in X.28 were critical for the other people. So I set up something and test everything during the weekend. And on Monday, I had the image. And I built a fix on the image of the customer. So the image was running plus the fix. So since the X.25 BU was busy with something and they wouldn't help me, I asked the BU selling the routers if they were interested to support it. Because we were potentially the only one providing this possibility to the customer. And there were a lot of routers they would eventually buy in the first phase and even routers after for another bank, because they said, if it works for us, I will contact the other bank and they will buy your routers too. So I heard 5 years after, it was like millions net that they eventually could take from this feature. and eventually I gave the image after the green light of the BU select the routers. I think it was 3900 or something, and then eventually it worked fine at the customer. He tested everything. He didn't have any more trouble. This image was running for like 6 months, I think, at the customer, and eventually, at that time, the BU of X.25 came back to me to officialize the feature and provide the fix and everything to the DE, and we did all the paper stuff, and eventually went to the CCO as a effective feature.
So
That's
it's
the
a router
story.
iOS you programmed and you enhanced
Yeah,
with adding a
it
feature.
was
Okay.
iOS. And then
And how do you even get started? How do you get the idea? Oh, let me just see the source code and see what I can do.
So you're back. Okay. So I helped the people of the bank, of course, because they find a vendor that was supporting this trouble. And then I helped the team of Greece, actually, because of this, they didn't have to fire people because of the amount of route they could sell. And eventually, I helped, I guess, a lot of people going to Greece for holiday that needed a POS transaction on those banks, because obviously you wouldn't have more.
That's not bad for one
Not all
weekend
the
of
time.
coding, right?
No.
Good impact, yeah. But how? I'm still confused. Like you're saying, it's a competitive advantage because only our routers had this feature and could help people. But how come like it didn't exist before? It's just no one had a line that was 1200 baud, or what was the deal?
But the thing is that the POS, the good one that were following the rules, they had this rule embedded in the EEPROM,
Okay.
and they knew when the 1200 baud is there. Although I met during the time that there were still X.25 coders in San Jose. They didn't want to change, but because they were strict on the rules. So they were forcing the customer to change the POS. But in this case, it was probably never going to be changed because I guess they would never build any new one because it was too expensive. And eventually, after 5 years, maybe it would have gone, to the garbage because all the new models with IP or DSL or whatever would have come out.
So what you did is actually to help supporting something that the POS doesn't because of bad coding on their side. So what you did is a nice thing on our side to support it anyway, and integrate that. That's correct, right?
Yeah.
It's actually nice. These guys can't do it, so let us do it ourselves. That's
nice.
But
so they had trouble, I guess, from the bank office to eventually replace or even maybe only this firmware, but eventually replace the POS would have been a lot more expensive, and so that's why. I mean, I had other solutions, maybe going via Autocommand Telnet and on their server and so on, doing stuff, but I think this one was less impacting.
It sounds to me like the IoT problem, but back then, because right now with IoT we have so many devices that do not behave as properly as you would expect, and then you need to have an infrastructure that can deal with it and tolerate it and fix it, and it's exactly what you did, right? The point of sale that didn't behave as it should, and it's the point of sale. It cannot be changed, so you have to deal with it.
Yeah, there are a lot. I mean, those small devices, they were everywhere in the shops at the time. We didn't have the phone to pay at that time. You only had that.
Still nowadays, you still have those point of sale devices anyway. You can pay by
I guess
card.
they're a bit more smart now. Probably they're going via IP or something like this.
And now that you mention it, Alain, why do we use X.25 in the first place? I mean, IP has been there a long time, so why those devices are not using IP from the beginning?
Oh, because that came from the bank, and the bank, I would say, maybe 20 or 5, they were doing asynchronous all the time. They had those concentrator with asynchronous. Even the ATM cash dispenser was on async. It was sending everything synchronous at the beginning. They were having all those modems everywhere. If I remember, some of those concentrator, the provider had here, I think at that time was Bank Contact. It was full of asynchronous modem in the bank, just concentrator with stuff asynchronous. So they kept on developing asynchronous stuff at the time.
Yeah, they prefer to keep X.25 rather to move to IP, right? I guess it was probably more profitable for them.
There you had this X.28 protocol, this X.25, everything was set correctly to handle this transaction. And eventually it was really nice because you could have one type of parity in asynchronous on one side and another type. Because of the X.25 in between, you could interact with a lot of stuff, even with different type of device on.
So it's really a protocol made for dial-up connection, right? It's built for dial-up.
This X.28 was a protocol to the rules for asynchronous when you talk to X.25 with padding and profiles and stuff like this. X.25 was supporting it, but I mean, you could even support PPP connection over X.25. This protocol was supporting everything.
Why would you do that?
I don't know. Somebody asked. We were supporting it. There were PPP packet going through X.25.
But is it really dead? Because you mentioned you still had a case last year about it. But if I check on Wikipedia, it's dead since many years. Like many countries just disabled it. So
there are some service provider, at least 2 years ago, we fixed the bug for him. And it was because they were testing this iOS XE in their environment. And they needed to support this because what's happening is that the server that does X.25, often they're very old application, and eventually nobody touch it, but it still works. So they need to develop something else, and the only support to with that server is X.25. That's why I guess this guy 1 or 2 years ago really had to support it over. I don't remember what it was for device. I think it was a 4000 ISR, which is actually iOS XE.
And so does that mean that the customer that are still running X.25 today, imagine there are some, do they need to have an entire X.25 backbone, or is there a way to carry X.25 over other protocols?
Oh, we are over TCP. I mean, most of the time they do it via IP network. So before, we also had actually it brought a lot of money at Cisco at that point, because you had those vendors or service providers, they were having pure X.25 nodes, but those were connecting with, I don't know, trunks of dedicated line anyway. So when Cisco came, they say, oh, but we support X.25 on this interface, and you can use IP network. They were transporting X.25 over IP with the XOT stuff. So a lot of customers that were already having an IP backbone were happy, because why keeping all those old X.25 nodes, and eventually, I can transport it via IP.
And XOT, it stands for X.25 over TCP.
Over
that's correct.
TCP.
Okay. Yeah.
So you're telling me that in 2024, we still have people who say, yeah, those devices, it would cost more to replace them with something newer. We have to keep running X.25, to the point where they even carry X.25 over IP rather than using IP, because that would mean replacing the device, right?
Yeah.
So they need to replace an infrastructure that is able to carry X.25 over IP, just because they don't want to replace those point of sale or whatever that can only
still. At the time, it was like that. Yeah. But actually, I think I went in France once, maybe 10 years ago, and they were doing the clearing of the mobiles with X.25. So the antenna, they were picking up some clearing, and they were using X.25 protocol because it was a very stable protocol. You have those windowing mechanisms and so on. If something is not transferred, it has to retransfer. So you had a very stable protocol to transport data. That's what they used at that time. And eventually, I think Sun Microsystem at the time, We even support it via some L2 support to the sun. From the router to it was called CMNF, and you could transport over Ethernet frame X.25, so they were not TCP, but pure Ethernet frame, directly into the sun. And the sun was treating this clearing of those antennas.
Well, this is so fancy. You have so many legacy protocols like that. They are so cool. I think I've known you for a while, Alain, like 15 years, if more. And I'm always amazed by the amount of protocols that you know. Every day that I listen to you, I hear one more protocol that I didn't know about. You must be one of the last one knowing that. That's so cool.
Yeah, asynchronous is another one.
There must be a time where people stop using those protocols. I don't know. Like the last people who heard about those protocols will die, and then what happens?
Asynchronous, I mean, you remember, Tristan, we had a case a few years, last year, pure asynchronous stuff.
Yeah, we still see those once in a while.
Yeah. And it was not just for a console, it was for, a lot of different stuff.
Yeah, this was cool.
And actually, when I deal with the other team, I often have asynchronous cases. Most of the time it's just to connect console, but sometimes it's for IoT or something like that.
Mm-hmm. Yeah, actually, some of those protocols, they come back into fashion, like you said, with IoT stuff, because, I mean, RS-232, you thought it would be dead. No, it's coming back on those IoT devices. Maybe X.25 will have a revival as well.
Who knows, maybe somebody would decide, actually, this is stable, I will introduce it again.
Yeah, indeed. This is cool. Thanks a lot.
It's not every day that you have a support technician, if I can call it like that, who codes a feature just for you and convince the engineering team to just put it in the code and there you go, right?
Yeah, actually,
I haven't heard it happen too much.
I did a bit of walk around because if I would have only waited for X.25, they wouldn't have done this because they were too busy. So I went through the other team that was selling the router.
Yeah.
But I mean, they agreed.
And
so that was,
to be honest, I understand, because when you do it properly, to develop a feature, you need testing, you need a lot of cycles, and you're just like a nerd who coded it during the weekend, on his couch.
Yeah,
so normally that cannot be trusted. So it's good that it was needed.
I knew
it worked.
the protocol very well.
Yeah, it was for one customer, like it could be tested.
Yeah.
It's not the normal process.
Yeah, because when the X.25 VU came back and they asked me, are we going to test this and so on? I told them it's working fine already 6 months at the customer. So you don't need to test.
The whole Greece is testing it for you and they're happy with it.
And eventually it took me more time to do all the paper stuff than potentially code the feature. Because we had to explain how many line code, what was changed and all that stuff. So it was a lot more work actually at the end.
It's quite impressive because we often hear on this podcast and in tech in general, people going the extra mile for the customer, like they think that it's way outside of their scope. And it's not just the extra mile that you did, it's like the extra marathon. You did like so many extra those miles for them with all the testing and all that.
Convincing people.
Yeah, the political work on this is more than the technical work, actually.
Yeah.
I'm trying to picture, the discussion. Can we have this feature? No, it's too complicated. Well, the feature is already there, and the customer is already running it, and it kind of works. So, how is that even possible, guys?
No. He says, no, we're too complicated. We're too busy. So I went to the other BU and says, do you want to support this customer and sell that many routers? And they said, of course.
The sales pitch was the right bit.
Yeah. And then that BU influenced, of course, the X.25 BU. They couldn't do anything else anymore. And then just supporting it. And of course, the sales also had me because I told him to push the BU also so that it came in. And eventually, I think it took 1 year total and then it was in CSO.
That's a long time. It's a long time to develop a feature that was already developed. Just verification, security, documentation, paperwork. Okay, well, thanks a lot, Alain. It was really nice having you.
Yeah,
Thank you.
thank you.
For interviewing me.
That's a unique story. If you have other stories, we'll have you back for sure.
Yeah. Okay.
Thank you.
Thank you.
Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us on Cisco Podcast Network and SoundCloud or in your favorite podcasting app. You can also find us on X at Cisco Tech Story without S. Thanks again for listening and speak to you next month.
Through haunted halls, encrypted rooms on ancient walls, ballad beats and arcane charms, God below with vigilant arms. Alain and his sorcery, it's all a grand show. Magic spells and protocols to and fro. From darkest code to the brightest spell, he leads a network from his enchanted well. Bites and bewitched frames, cast by wizards, gone by names. Ether flows through spectral chains, connecting realms with endless rays. Telepathic signals fleet, crossing paths where shadows meet. Protocols infused with might, in the depths of endless night. Alain speaks in silent tongues, mystic codes from distant lungs. Quantum spells and virtual links, binding realms in unseen space. And his sorcery, it's all a grand show. Magic spells and protocols to and fro. From darkest code to the brightest spell, he leads a network from his enchanted well. Alain and his sorcery, it's all a grand show. Magic spells and protocols to and fro. From darkest code to the brightest spell, he leads a network from his enchanted well. Yeah. Bewitched phrase, cast by wizards, gone by names. Ether flows through spectral chains, connecting realms with endless rays. Telepathic signals fleet, crossing paths where shadows meet. Protocols to and fro. X.25 and bewitched frames, cast by wizards, gone by names. Ether flows through spectral chains, connecting realms with endless rays. Telepathic signals fleet, crossing paths where shadows meet. Protocols infused with might, in the depths of endless night. Alain speaks in silent tongues, mystic codes from distant lungs. Quantum spells and virtual lace, binding realms in unseen space.